Let's do example 6, question 1. Determine the vertical and horizontal asymptotes of the following functions. For vertical, you need to use vex t, and for horizontal asymptote, you need to use high t. So let's start with question A. Here is your fx. So let's find vertical asymptote first, and we're going to apply vex t. VA stands for vertical asymptote. Next is small a. So we need to find what is the value of a, and it always comes from your denominator. Let it equal to 0, and hence you can see that x is equal to 1. So this is your a. So for the second step here, you're going to consider x approaching 1 from the right hand side and x approaching 1 from the left hand side. The third step is small x. And for this step, you're just going to write down x equal to a is the vertical asymptote. And we already know that a is 1. The final step is capital T, and this is your table. So we're going to have 4 columns. The first column is x, the second column is left hand side, the third column is right hand side, and the final column is your conclusion. In the first column here, just put the value of x, which is 1. So this means that you're going to consider x approaching 1 from the right hand side and x approaching 1 from the left hand side. So before we do this step, draw your number line for this function. That's your x-axis. Okay, so for this function fx, x must not equal to 1. So this means that at x equal to 1, there is no fx. Therefore, we're going to put an empty circle. So this function fx is for all values of x except x equal to 1. So fx only exists in this area and this area only. There is no fx when x equal to 1. Now let's do our table. For the second column, we have left hand side. So we need to find the limit of fx as x approaching 1 from the left hand side. So here is 1. X is approaching 1 from the left hand side, and you can see that on the left hand side here, this is your function fx. So change fx. Substitute x equal to 1 into x. So for the first term here, x is just 1, and then we have 1 minus 1, which is 0. So that's for the first term. But don't forget that we have this second term here. So substitute x equal to 1 into 1, it's just 1. So if you look at this first term, only the denominator is 0. So we need to find whether this is 0 positive or 0 negative. So from the left hand side of x equal to 1, we're going to pick 0.9. So substitute 0.9 into 1 minus x. And that will give you 0.1, which is 0 plus. So this is 0 plus. This is case 3. So that will give you infinity. So is it positive infinity or negative infinity? 1 is positive. 0 plus is also positive. So positive divided by positive is positive. But don't forget we have plus 1 here. Infinity plus 1 is still infinity. So for the left hand side, the answer is positive infinity. Now let's do the right hand side. Find the limit of fx as x approaching 1 from the right hand side. So this is 1, and this in from the right hand side. So we can see that this is our fx. So substitute x equal to 1 into x. For the first term, we're going to get 1 over 0. And when we substitute this into the second term, we will get plus 1. only the denominator is 0. So you need to find whether this is 0 plus or 0 minus. From the right hand side of 1, let's pick 1.1. So substitute 1.1 into 1 minus x. So 1 minus 1.1 is negative 0.1, and hence this is 0 minus. So this is 0 minus. And we know that this is case 3, where you will get infinity. So is it positive or negative? 1 is positive, 0 minus is negative. So positive divided by negative is negative. But don't forget we have plus 1 at the back. So negative infinity plus 1 is still negative infinity. Therefore, for the right hand side, negative infinity is the answer. Now let's make the conclusion. For the left hand side, we have positive infinity. For the right hand side, we have negative infinity. So here are our answers. For vertical asymptote, as long as you can see infinity, whether it is positive or negative, it is not important. As long as it is infinity, this means that this statement is correct. So just copy down this statement back into your conclusion. Therefore, x equal to 1 is the vertical asymptote. So that is how you find vertical asymptote using vex t. Next is the horizontal asymptote, and it means that you need to use high t. HA stands for horizontal asymptote. I stands for infinity. So this means that you need to find what happens to fx as x approaches positive infinity and x approaches negative infinity. Next, we have y. For this step, just write down y equal to something is the horizontal asymptote. And finally, we have t, which is the table. And for the table, we're going to have 4 columns as well. X, left hand side, right hand side, and conclusion. For the first column, put the values of x here. So, x is approaching positive and negative infinity. Let's start with the first one, which is left hand side. As x approaching left hand side, x approaches negative infinity. So for this one here, you need to find the limit of fx as x approaches negative infinity. And on the left hand side, our function is this fx. Since x is approaching positive or negative infinity, if you have two functions here, separate it into two limits. Like this. Now substitute x equal to negative infinity into x. Let's do for the first limit here. You can see that this will give you infinity over infinity, which is case 5. So divide everything with the highest power in the denominator, which is x. And for the second limit here, this is simply 1. So plus 1. Simplify the first term. Now let's substitute x equal to negative infinity back into x. And this is 0. Therefore, this is actually 1 over negative 1. This one is plus 1. The first term is actually just negative 1. And hence, the final answer is 0. So, this is the answer when you consider the left-hand side. For the right-hand side, as x approaches right hand side, x approaches positive infinity. So here, this is actually the limit of fx as x approaches positive infinity. And we know that on the right hand side here, this is fx. And if your x is approaching infinity, if you have two terms, just separate it into two limits. And now just substitute x equal to infinity into x. For the first limit here, you can see that this is infinity over infinity, which is case 5. So the highest power is x. This means that everything here should be divided by x. Now let's simplify everything. For the first limit here, this is actually just 1. But don't forget we still have plus 1 at the back. So now, substitute x equal to positive infinity back into our limit. So for this limit here, this is 0. And hence, this is 1 over negative 1, which is just negative 1. Positive 1 stays the same. And the final answer is 0. From the left hand side, we get 0. From the right hand side, we also get 0. And we're gonna use this in order to make our conclusion. Note that for conclusion, you need to write y equal to something is the horizontal asymptote. So put this into our conclusion. So, what is this value of y? Note that the value of y comes from your answer. Since both answers are the same, this means that it is just y equal to 0. Therefore, here, this is actually y equal to 0. And hence, y equal to 0 is the horizontal asymptote.